Today I'm going to explain the assignment of electrical drive, which we need to construct DC motor permanent magnet and try a few cases on it based on the objective given. This is the design of DC motor permanent magnet. So this is the question show what need in case A, case B, case C and case D, where we need to apply in simulation and see what happened to the graph of speed and torque. First, we need to test the speed rating where the parameters are already given. So here is the H bridge. This is a DC motor permanent magnet, and here is the output for the motor speed and torque, and this is the cascaded PI controller, and here is torque controller, and this is speed controller. So we're going to test on the parameter here. As we can see, the parameter of motor voltage is 220 volt, for motor speed is 1470 rpm, and motor current is 8.3 ampere. For value RA and NA, we just need to insert to this DC permanent magnet. Then run the simulation. As we can see, our speed rating is 1470 rpm, which show that it is achieved to the parameter given. For the case A, we need to change the input to reference input in order to show that it can operate in all four quadrants. As we can see, this is graph of speed, torque and power. When we give input to the load, it will increase. The torque still can follow up with the reference. The speed also can follow the reference, but still need to adjust the PI controller for speed. But as long as the part of quadrant can follow, so it is okay. The power keep follow up with the speed and torque. When the speed increase, so does the power. For the case B, we need to show that the motor can be controlled beyond its rated speed and analyze the controller performance if the speed rating exceeds. As we can see here, our motor cannot exceed its rating speed, so does the torque and the power fall to the rated. Next, for the case C, we need to show that the motor can be controlled beyond its rated torque. From the graph, we can see that as the torque increase, the speed starts to fall beyond its rated torque, and it falls to the reverse quadrant and increase back to 0. As it falls, the speed tries to raise again, but there is no load, so the speed cannot reach the reference needed. For case D, we need to evaluate the efficiency of drive system when the motor is operating at its rated speed and torque. We set constant value to 10 and change the step time to be more longer. So this is the graph for case D, where we can see the torque already maintained. For the yellow line, it is the reference to torque, and red line is the load. And for the blue color is torque for the motor. In 3 seconds, it still cannot reach the rated speed for motor, but torque still can follow the reference, so it's not fall. As we can see, the torque can cooperate with the motor, but speed cannot reach to the rated speed, so our efficiency is not efficient.